Testing requirements are becoming more complex to more closely reflect the scenarios that vehicles can encounter on the road. Our unique swarm testing capability allows us to recreate them precisely. AB Dynamics is unique in the automotive industry with a toolchain that enables tightly controlled multi-vehicle tests in both the simulated virtual world and on the test track. Simulation has an essential part to play in vehicle development, particularly with the advent of assisted driving and autonomous vehicles, where it allows testing on a scale that would never be possible otherwise. However, for that simulated testing to have value to engineers, validation and correlation of the results with real-world testing is of paramount importance. Engineers need to have confidence that a test run in the virtual world will have the same result as if it had been run on the track. AB Dynamics has a range of simulation solutions under the AVDS brand, ranging from workstations to highly dynamic motion platforms. We use the same test definition files to control the actors on the test track and to define scenarios within the RF Pro virtual environment. On the test track, we're using various AB Dynamics driving robots to control and synchronize the swarm of vehicles. Our GST and Launchpad platforms can also be incorporated into the swarm scenario. All are controlled from a common software environment. The subject in these scenarios is the white Kia. Let's look at some examples of how the toolchain is used. The cut-in test replicates a high-risk scenario that you could encounter on a highway. The GST cuts into the middle lane in front of the vehicle under test, forcing it to take evasive action. The vehicle under test is unable to overtake the GST as another vehicle overtakes at the same time, blocking the outside lane. So instead, our test vehicle must brake to avoid hitting the GST. In the cutout scenario, the subject vehicle is following another car which suddenly changes lanes, revealing a slower moving or stationary vehicle ahead. The other traffic vehicles are positioned to limit the choices available to the vehicle under test. Automated lane keeping systems are seen as the next stepping stone towards full autonomy. This is an example of something they must cope with in order to be used safely. Human drivers are unpredictable and all react differently to a particular scenario. A lane closure offers a good example of this. A driver may behave in different ways depending on their mood, and an autonomous vehicle must interpret the intentions of the drivers around it to navigate safely through. Here, our vehicle under test is travelling in a lane which is blocked by cones without warning, and with traffic in the adjacent lane. It needs to determine whether it can merge into another lane or needs to brake hard before the lane closure. Simulation allows us to test out thousands of variations of a scenario and identify the key edge cases. A subset can then be validated on the test track using our patented synchro motion control technology. All the actors are controlled with centimetre accuracy, even at highway speeds. AB Dynamics toolchain gives you confidence in the results of your simulation and validation. When driving in the real world, autonomous vehicles and ADAS systems must understand and interact with a variety of other moving and stationary objects. AB Dynamics robots can be used to control a wide range of other traffic vehicles, from small passenger cars to buses or large trucks. Here, the Launchpad platform is used to add a vulnerable road user into the scenario. The GST and Launchpad platforms are also available within the RF Pro virtual environment. AB Dynamics is unique in its capacity to deliver advanced swarm testing across simulation and real proving grounds. Talk to us today about how our toolchain can help you with your AV and ADAS test programs.